Hi everyone. In this video I am going to analyze 2022 first term Wezary Ministry Physics questions, and I'm going to answer them. First I'm going to talk about the exam in general. 2022 Ministry Physics exam, distribution of the questions were like this. From 50 questions, 17 of them were repeated. So repeated question means the questions which are asked previous years and asked again, exactly the same questions. Which means if a student only learns these questions, she would get a mark which is 34 from 100. And 8 questions were modified. Modified means previously asked questions are changed. Generally, these are problems. One number is changed with another number, or a problem is asked in a reverse way, or a definition is asked in a reverse way. It's modified. Yeah, and it's very close to previously asked questions. So which is 8. So total becomes 25. So when a student studies the questions which are previously asked in details, so that student can get from physics 50 from 100. And other 25 questions are new questions which are not previously asked. But from these 25 questions, now I'm going to solve them in coming minutes. Several questions are from the book, and only small changes are done in the questions in the book. Titles were in the book. Just 2 or 3 questions are a bit different to separate students who are good at physics. And from these 50 questions, 25 of them were definitions or conceptual. So 50% of ministry questions of 2022 first term was conceptuals. I mean only questions, definitions, but other 25 and 50% was problems, solutions. Generally, every year it's happening in this way. So about 50% or a little less than 50% problem. So 50% or 55% is conceptual or definitions. And distribution of the questions were there was not so big difference between the previous years and this year. Previous years, for example, chapter 1, there were 5 questions asked. This year, again, 5 questions. There is no so big difference between previously asked questions and this year. Chapter 2, there were 5 questions, previously asked questions in average, but this year they asked 2 more questions and 7 questions. So chapter 2 questions increased when we compare to previous years. Chapter 3 questions, average of the previously asked exams questions of chapter 3 was 7, but this year it was 6. Yani 1 question less compared to previous year exams. Chapter 4 questions were it was previous year's average, on average 4. This year it becomes 5 plus 1. Chapter 5 questions, average of the previous years were almost 5. This year is again 5. There is no change. Chapter 6, average of the previous years was 11. This year is 12. So plus 1. So 1 question more compared to the previous years. Chapter 7, previous year average is 4, but this year is 3. one question is less. Chapter 8, previous year's average is 5. This year's was 4. One question is less. Chapter 9, previous year's average is 4. This year's was 3. One question is less. So as you see, in chapters 7, 8, and 9, because of the pandemic, these chapters are not studied previous years, and that's why it's the 2 years later, after 2019, these chapters are asked. We were expecting to be asked more questions, but as you see, it happened opposite, so less number of questions are asked from these chapters. One more surprising thing is about chapter 6. Generally, questions in chapter 6 distribution was like this. Generally, section 3 questions, average of the section 3 questions every year previously asked exams was 7, but this year happened very surprising. So chapter 3, section 3 questions of chapter 6, this time asked for alternating current circuits. Chapter 6, section 3 questions are very less number of questions compared to previous years, but instead of this, section 1 questions are increased. These 3 questions in chapter section 3 is transferred to section 1 of the chapter 6. So as I said, the 25, these 70 questions were repeated questions. 8 questions are modified and 25 were new. So just quickly we will answer them. The first question is about the definition of centripetal acceleration. So this question is asked in 2017 and then asked in 2022. So it is the time rate of variation of direction of the velocity of an object when it moves on a circular path. It is the centripetal acceleration. This definition is given in this way in the book, so which is just you are going to learn it. Second question, repeated question, is a definition of a lever arm. So 2013, 17, 19, 21, 22. So lever arms definition is very popular in ministry questions. It is a perpendicular distance from the axis of rotation to a line drawn along the direction of the force. So this definition is exact definition which is in the book. Question number 3 is twice asked, 2015 and 22. Identify in which of the following situations both conditions of equilibrium are not applied. So here is not applied is the key. There will be no translational equilibrium, there will be no rotational equilibrium, none of them. So it is the answer of this question is C, because in a constant speed, in a object rolls at constant speed, both angular speed constant, linear speed is constant, and if speed is constant, equilibrium exists. So it says not exist, not applied. So this is not the answer. Parked, bicycle parked against the curb. A bicycle park means at rest. If an object is at rest, both conditions are applied, but the question is not applied. A football traveling through the air. Football traveling through the air. Translational equilibrium not applied, but rotational equilibrium is applied. But we are looking for both not applied. Both not applied. So it is the C. So if an automobile is tire is braking, automobile is braking. So angular speed of the tire is decreasing, linear speed of the tire is decreasing. So if speed, both linear and angular speed changes, in this case, there will be no translational equilibrium, no rotational equilibrium. C is the correct answer for this question. Question number 4 is a twice asked ministry 2013, 2022. It's about how to convert galvanometer into ammeter. So we are going to connect a galvanometer into ammeter by connecting a very low resistance in parallel with the galvanometer. So it is A, and this question is exactly explained in this book in this way. Question number 5. Which of the following does not affect the period of mass spring system when it moves with simple harmonic motion? Spring constant, mass and spring and then period of the vibration. So you can write the equation for period of mass spring system. You can check it, which is 2 pi m over k. So the quantities which are in this equation will affect. Which one is not in this equation will not affect. So mass is in the equation, spring constant in the equation, so they will affect. But amplitude is not in this equation. And also, we have to know that amplitude of the vibration does not affect period of mass spring system, and also does not affect period of the simple pendulum. And question number 6. Twice asked 2018 and 2022. It is Tesla times ampere times meter is equal to what? So Tesla is unit of magnetic field. Ampere is the unit of electric current. Meter is the unit of length. BIL is the equation for magnetic force. So what is unit of magnetic force? It's the Newton, of course. Newton is unit of magnetic force. It is A. Question number 7. Blah blah waves can be used to produce image of the object inside the body. This is 3 times asked ministry. It is ultrasonic sound waves. Sound waves are used to produce image inside the human body. So ultrasonic sound waves, because they have very short frequency, very short wavelength, they can reflect very easily from the small particles inside the human body, and that's why they can produce an image. Infrasonic has a very long wavelength compared to ultrasonic. Automobiles also have a very long wavelength. They cannot be used for imaging the human body. And question number 8. Henry is equal to what? Henry is equal to what? Repeated question. This is also a repeated question. I think last year this one is asked. I forgot to write in here. 2021 and 2022 questions. Henry. Definition of the Henry. We are going to use the equation which includes Henry. E is equal to negative L delta I over delta T. This was the one of the equations. So Henry is the unit of coefficient of self-induction when cross product is done. So L is going to be negative E delta T divided by delta I. So Henry in this case is going to be equal negative E is volt. Negative does not include because we are just looking for the unit. E is volt. Delta I, electric current, is ampere. Delta T is second. So volt per ampere, according to Ohm's law, remember in the 11th grade you learned V over I. Volt per ampere is equal to Ohm. Instead of volt per ampere, I'm going to write Ohm. So in this case, Henry is going to be Ohm times unit of times second. Yani C is going to be the answer in here. Question number 9. Twice asked ministry question. Which quantities remain constant when alternating currents are generated in a generator? When a generator is, every generator has a current frequency which is constant frequency, which does not change. Because a frequency does not change, maximum value of the induced EMF, which is Banu, does not change. BAN omega. B for a generator constant, area of the loop of generator is constant, number of turns in a generator constant. So you don't change this when a generator is manufactured. And every generator rotates at a fixed frequency. For example, in Asia it is 50 Hz, United States 60 Hz. These numbers are constant. So current frequency, maximum value of the potential difference, which is Banu. If the maximum value of the potential difference is constant, so maximum value of the current is also constant according to Ohm's law. So all these 3 are constant. Question number 10. Which object would produce the most distinct diffraction pattern? 3 times asked question in ministry. The one who has the smallest size produces the most distinct diffraction pattern. Which one is the smallest in size? Of course, human hair. C is the correct answer. 1 electron volt is equal to, this is 2017 question and also asked this year. It's the equivalent of electron volt in joule, 1.6 times 10 to the power of negative 19 joule. Question number 12. Which type of spectrum is used to identify elements in the atmosphere? This is the keyword. Atmosphere of the star. Absorption spectrum, because light coming from the nuclear fusion of the star is passing through the atmosphere, and the photons whose energies match the energy separation between the gas of the atmosphere and the star are trapped, and those positions appears dark, and these dark lines in a continuous spectrum come from a star is called as absorption spectrum, so it was B. It's three times asked in ministry. Question number 13. The PN junction conducts current. PN junctions, it's a diode. Diode allows electric current only in one direction if the diode is forward biased. If a diode is forward biased, it allows electric current in only that direction. 3 times asked ministry question. Which of the following is the equation represents the relation between the collector current and base current in a transistor as it works in an amplifier? So this equation 3 times asked in ministry, and this equation is in the book because collector current is always greater than base current. Collector current is beta, which is the current gain times base current of the transistor. And these are conceptual challenge problems about repeated problems, but the 3 problems are repeated in a problem session. Question number 15. A frequency is given f, calculate the period. So what is t? So we are going to use equation between t and a, f, which is 1 over f. So 1 over 5. 1 over 5 is how much? 0.2 seconds. So same question, same way, just maybe numbers are different. As asking 3 times. So which is 0.2. Question number 16 is also asked in ministry before with these different numbers, but the sentences are the same always. A wave of amplitude 0.75 has the same wavelength as the second wave with amplitude of 0.53. 2 waves interfere. What is the amplitude of the resultant wave? If the interference is constructive, in constructive interference, you are going to add the amplitude of each wave, 0.75 plus 0.53. Result is going to be 1.28 meter. So this is the correct answer, and this is in this way asked in ministry 3 times. And the last repeated question is 17. A pair of adjacent coils has a mutual inductance mu, which is 1.06 Henry. Determine the average induced EMF E in the secondary circuit is the question. When the current in the primary circuit changes from 0 to 9.5, which is delta I, in a time interval of 0.0336, which is delta T. Equation for mutual inductance is negative M delta I over delta T. So delta negative M is 1.06 times delta I is 9.5 minus 0, which is 9.5, which is an increase, divided by 0.0336. So 1.06 times 9.5 divided by 0.0336, result is almost 300, negative 300. Okay, let's continue now with the questions which are modified. Question number 8. It is one of the modified question. Which of these periodic motion is simple harmonic motion? Just according to angle, we are going to define this. Angles of the swing less than 15 is going to be the simple harmonic motion. Now, in the first one is the swing is the angle has 45. This is not simple harmonic, only periodic. See the rotating in a player without a vertical axis. It's repeated motion. It's not. It's just a periodic motion, not simple harmonic. And oscillating clock pendulum, but the angle is greater than 15. This is not. Correct answer is D in here. Question number 19. Which of the following factors will change when the sound gets louder? Now, loudness is about the power of the source, and power of the source determines the energy of the sound wave. Energy of the sound wave determines the amplitude of the wave. Amplitude and energy determines the intensity of the wave. Intensity determines the loudness or relative intensity beta. So as one of them increases, all of them increases. If one of them decreases, the other one decreases. So it gets louder, which means as to get better, louder, greater, I can get greater, amplitude can get greater, energy of the wave can get greater, power of the source can get greater. So intensity, yes. Amplitude, yes. Relative intensity beta, yes. So all answers are correct. All answers are correct. Question number 20. A disk starts from rest. So its initial angular speed is 0. After 4 seconds, which is delta t is 4 seconds, its angular speed is 2 radian per second, which is omega final is 2 radian per second. Calculate the tangential acceleration of a point on the disk, this disk that is 0.1 meter from the axis of rotation. So a tangential acceleration AT is the question. At a distance of 0.1 meter from the axis of rotation means radius of the path followed by this point is going to be 0.1. So to calculate AT, I need to know what alpha is, because AT is equal to R times alpha. So alpha can be calculated from this given in here. Alpha is equal to omega final minus omega initial divided by delta t. So omega final is 2, initial is 0, divided by 4. Alpha is going to be 0.5 radian per second. AT is going to be R times alpha. R is 0.1, alpha is 0.5. When we multiply them, answer is going to be 0.05 meter per second squared. B is the correct answer. When decibel level of traffic in street goes from 4 decibel to 6 decibel, this is initial relative intensity. This is final relative intensity. How much greater is the intensity of the noise? How much greater intensity of noise means compare final sound intensity by the initial one. Yani, what is I final over I initial? So this is the question. When I was explaining this to you in the classroom, so I just showed you without a logarithm a hack for this. If you know beta final, yes, we know which is 60 decibel. And if you know beta initial, which is 40 decibel, so I final over I initial is going to be, so just you are going to write 10 and 10 for numerator and denominator, and then clean 1 0. Put this 6 in here, put this 4 right there. It is 10 to the power of 6 divided by 10 to the power of 4, which is 10 to the power of 2. 10 to the power of 2 is the answer, and B is the answer in here. And this is modified, but with the same number, different numbers. The same question is asked 3 times. Question number 22. A proton moving east experiences a force, magnetic force, which is F magnetic, upward to the sky due to the Earth's magnetic field. At this location, the field has a magnitude of 5.5 times 10 to the power of negative 5 Tesla, which is magnetic field to the north. Find the speed of the proton. So V is the question. V is the question. So if the charge also given, so we are going to use the equation for calculating magnetic force. Fm magnetic, which is equal to QVB. So V is the question. So to calculate the V, I have to simplify Q and B. Right, dividing Q and B. simplify them. So V is going to be F magnetic divided by Q and B. So F magnetic is 8.8 times 10 to the power of negative 19. Charge of the proton is given in the question 1.6 times 10 to the power of negative 19. Multiplied by, it isn't 16, but it's 19. Multiplied by B. B is given at this location 5.5 times 10 to the power of negative 5 Tesla. And when you calculate them, answer is going to be B. B is the answer. Yani 1 times 10 to the power of 5 meter per second. Question number 23. Calculate the power lost as a heat in a wire of resistance R when traversed by a current of 50 ampere. This current is, if not set the maximum value in the problem, it's the effective value of AC or just direct current. So if effective value of the alternating current power equation is I effective squared times R. So if direct current doesn't matter, I squared times R. If question says the given current is maximum value, so equation is going to be IM squared R divided by 2. But not set, that's why I will consider this current is to be direct current constant value, which will be effective value of the AC. 50 squared times 120. So when we calculate it, answer becomes C, which becomes 300,000 watt. When we convert 300,000 watt to watt by dividing 1000, it becomes 300 kilowatt. Question number 24. A step-up transformer is used on a 120 volt line to provide a potential difference at 2400. So if the line is 120 volt, it is going to be V1, and we are going to increase this V1 to V2 by using a transformer, 2400. If the primary has 75 turns, which is M1, how many turns are there in the secondary? What is N2 is the question. So transformer equation, we are going to use N2 divided by N1 is equal to V2 divided by V1. We know that directly proportional number of turns and potential difference, the primary and secondary coil, directly proportional. N2 is the question. N1 is given 75. V2 is 2400 divided by V1, which is 120. So if you use your calculator, you will get the answer as A. So I'm not going to calculate again, but the answer key is given as A in the K terms. Question number 25. Okay, this is the last repeated question, but modified one with different numbers. Distance between two cells, which is D, 0.03 millimeter. The second order bright fringe, which is M is equal to 2, but bright constructive interference measured on a viewing screen at an angle of 2.015 from the central maximum. Determine the wavelength of the light. So the bright fringe, I'm going to use the equation for constructive interference. We know that D for constructive interference, D sine theta is equal to M times lambda. Because I will calculate the wavelength, I have to simplify M. Divide by M, simplify M. So lambda is going to be V sine theta divided by M. D is given in millimeter, but I have to write it in meter by multiplying 10 to the power of negative 3. Millimeter is converted to meter by multiplying 10 to the power of negative 3. Multiplied by sine of angle is 2.15 divided by M. It is the second order bright, so M is equal to 2. And after that, we are going to use the calculator. So we will find lambda. We will get the answer in lambda first. In meters, 0.03 times 10 to the power of negative 3 times a sine of 2.15 divided by 2. This is the 5.62 times 10 to the power of negative 7 meter, but choices are given in nanometer. So I have to multiply this number by 10 to the power of 9. So meter is converted to nanometer by multiplying 10 to the power of 9. When we calculate 10 to the power of positive 9, I will get the answer 5.62 times 10 to the power of 2 nanometer. So it's going to be, the closest answer is B. Pardon, both are given. B and D, yeah, choice given. One of the choice must be negative, I think. Yes, I forgot to put. So D is given the correct answer. D is the correct answer. Question number 26. The distance between a node and the next antinode in a standing wave is equal to. Node to node is asked before. Antinode to antinode can be asked before, which is node to node, antinode to antinode. It is lambda over 2. But from a node to antinode, it's lambda over 4. I several times repeated in the question. In 1 year, they will ask this question. Do you know it? And this year, they ask that. So node to node, lambda over 2, antinode to antinode, lambda over 2, but node to antinode, which is lambda over 4. Question number 27. The figure shows the pattern of a double-slit experiment. The center maximum located at E. This is the central bright fringe, central maximum. Which point represents the second order minimum? Minimum dark. Which one is second dark? So this is central line. The one on the right, first dark, second dark, third dark. On the left, first dark, or first minimum, second minimum, third minimum. So it's asking you second order minimum. There are two second order minimum, which is H and B. H and B. D is the correct answer. Question number 28. When a bar magnet is moved away from a coil, then direction of the magnetic field of the induced current in the coil is what? So there is a coil and a bar magnet is moved away. So it doesn't matter this is N or S pole. If a bar magnet recedes away from a coil, according to Land's law, applied magnetic field of this bar magnet at this region decreases. And Land's law says that if magnetic field between the coil and the magnet decreases, the coil reacts at this decrease and try to keep the total magnetic field constant by producing a magnetic field which supports the applied magnetic field, and induced magnetic field this time, in the case of receding magnet, in the same direction of the applied field. This is the Land's law. Land's law. Question number 29. The graph is given. A graph shows the change of induced EMF with time t is depicted by a sine wave as the loop rotates in the magnetic field. At which point is the plane of the loop is parallel to the direction of the magnetic field. When the rotating coil takes a position parallel to magnetic field, induced EMF gets its maximum value. So at which point induced EMF is maximum value? Positive maximum and negative maximum. So B and D. At B and D, so induced EMF gets the maximum value. D is the correct answer in here. Question number 30. Which of the following is true for calculating the coefficient of self-induction of the solenoid? This equation is given exactly the same way in the book. Mu n squared A over L is the equation B. And let's continue with next question. Question number 31. This question is in the text, not as a question, but it is an explanation at the beginning of the section 1 of chapter 6. Consider a conducting wire pulled through the magnetic field as shown in the corresponding figures. The polarity of the induced EMF, which are the following corrects? So as you see, A, B, C, D, in all cases, the conductor is pulled to the right. Yani your thumb must show to the right. And magnetic field is out of the page. Yani your forefinger must show out of your page. Yani your forefinger is out of the page, but thumb is to the right. In this case, palm will show the end, which is positively charged. Opposite of your palm will show the end of the conductor, which is negatively charged. According to that, so A is correct. Question number 32. According to Einstein's photon theory, the number of ejected electrons from the metal depends on. So, to remove a photoelectron from a metal, so a photon must go there. So, one electron removed by one photon. 2 electrons are removed by 2 photons, 3 by 3 photons, according to Einstein's model. A number of photons determines what? Determines the intensity of the light, of course. So intensity of the light is the correct answer in here. Question number 33 is from the book text. So this band diagram belongs to conductor, insulator, semiconductor. A band gap if about 1 electron volt, it's semiconductor. If it is greater than 1 electron volt, just like close to the 5 electron volt, it's insulator. Less than 1 electron volt, when almost conduction when valence band coincide, is the conductor. So this is clearly explained in the book. And question number 34 is the first time this question is asked in this way. Generally, in the previous exam, J only asked just one part and just one given. But this time, 2 things calculated in one table. One of them is the angular displacement, the other one is on angular speed. So angular displacement will be calculated in radian. So equation of the angular displacement delta theta is delta S over R. Delta S over R. And delta S is given 0.25. R is given as 0.1. Result is going to be 2.5 radian. So 2.5 radian, it can be, answer can be A or C. How about omega? Omega is calculated by how? Vt is given tangential speed. R is given, omega is calculated. We know that Vt is equal to R times omega. If omega will be calculated, so it's going to be Vt divided by R. Vt is given as 1.5. R is given as 0.1. Result is going to be 15. 15 radian per second. So choice is correct, both correct. 2.5 for angular displacement, 15 for omega. So it's correct answer. Question number 35. 2 small masses that are 10 centimeters apart attract each other with a gravitational force of 10 times 10 to the power negative 11 Newton. When they are decreased 5 centimeters apart, yani R changes. This is R over 2. How do I know that? Because it changes from 10 to 5. How can you change 10 to 5 by dividing 2? Yani if the separation halved, what happens to the force? And we know that gravitational force is proportional to inverse square of the separation, and 1 over R squared. If R changes to R over 2, so this is initial value. A final value is going to be what? F final. Let's get it. If R changes to R over 2, I am going to write instead of R over 2. But I had to square both R and 2. So it's going to be 1 over R squared over 4. Flip this R squared over 4. 4 will go up to numerator. R squared will stay in denominator. If I rewrite this, this means 4 times 1 over R squared. How 1 over R squared, when it's 1 over R squared, answer is 10 times 10 to the power of negative 11. Right here, 10 times 10 to the power of negative 11 Newton. But final force is going to be 4 times of that number. Yani 4 times 10 times 10 to the power of 11, it becomes 40 times 10 to the power of negative 11 Newton. Yani force increases by 4 times. And question number 36. Which of the following is correct for 2 points A and B for a merry-go-round rotating about a fixed axis? Merry-go-round is a rigid object. For a rigid object, every single point on the object will have the same angular displacement, same angular speed, same angular acceleration. So angular quantities are same. Yani omega A and B are the same. They are same. Yeah, A is correct. B incorrect. Tangential speeds, the one which is farther will have a greater tangential speed. Which one is farther? Of course, A is greater than, but could you say B is greater than A? No, this is not correct. They cannot be equal. The tangential speeds or different distances will be different. So A is correct answer in here. This question is one of the chapter 2 question. Until this time, not asked ministry. The first time this question is asked in ministry, it is the arm of a crane at a construction site is 15 meter long, and it makes an angle of 20 degrees with the horizontal. So this is a crane. Let's draw a crane. Those cranes are generally on a truck or lorry. So this arm of the crane is from axis of rotation to the top is 15 meter long. So it is going to be the distance 15 meter long. And it makes an angle of 20 degrees with the horizontal. So with this horizontal line, the crane arm makes 20 degrees. Assume that the maximum load the crane can handle is limited by the amount of torque the load produces around the base of the arm. Base of the arm is the axis of rotation. What is the magnitude of the maximum torque the crane can withstand if the maximum load the crane can handle is 450? So the load is suspended from the top of the crane, so it produces a force which is equal to its weight. This force is given in the question as 450 newtons. So calculate the torque produced by this force, this load. The torque equation is F d sine theta. F is given, D is given, but angle theta is the angle between the force and the distance line. So we need this angle. But the given angle is not that angle. We have to calculate what is theta first. This is a right angle triangle. In right angle triangle, so 20 plus theta must be equal to 90 degrees. So theta is going to be, in this case, 90 minus 20, which is going to be 70 degrees. Then insert the given equation. F is 450. Distance is 15. Sine of 70. So let's use the calculator for this. 450 times 15 times a sine of 70. Answer is 6,343. So Newton meter is the torque produced by the crane arm. Question number 38 is one of the practice problem in chapter 2 section 3. It's also the first time asked. The potters wheel that has the shape of a disc at a radius of 0.5 meter and mass 100 kilogram, freely rotating 50 revolutions per minute. The potter can stop the wheel in 6 seconds by pressing a drag against the rim. How much torque does the potter apply to the wheel? So we will calculate the torque. But for calculating this net torque, we have to use Newton's second law for rotation, because there are two ways for calculating net torque. One of them is using definition of the torque, which is Ft sine theta. In this question, no F is given. So we have only one way. The second way as for calculating the net torque, which is torque net is equal to I times alpha. And I, because it's the shape of the disk, I for the disk first must be calculated, which is going to be 1 over 2 m of the disk and square of the radius. So 1 over 2 mass of the disk is given as 100. Radius of the disk is given as 0.5, but we should square it. Answer will be in here. I think 12.5 as I remember, because the same question in the book, this one, multiplied by 100 times 0.5 squared. Yeah, it's 12.5. So moment of inertia of disk is 12.5 kilogram meter squared. Now, second, to calculate the net torque, we need to know what moment of inertia, so we calculate, and also we need to know what alpha is. Initial angular speed of the potential is given, omega initial, but this is given in revolution per minute. We have to convert revolution per minute to radian per second by multiplying every one revolution 6.28 radian, every 1 minute is 60 seconds. So 50 multiplied by 6.28 divided by 60, it's going to be 5.23. 5.23 radian per second is initial angular speed, and in 6 seconds, which is the delta t, we are going to stop this wheel, which is omega final is 0. So we can use, by using definition of the angular acceleration, alpha, which is omega final minus omega initial divided by delta t. So omega final is, we will stop it 0. Initial omega is 5.23 radian per second, we just calculated, divided by delta t, which is 6. So when we divide 5.23 by 6, which is going to be negative, alpha is going to be negative 0.87 radian per second squared. After that, we will insert both I and alpha in this equation for calculating the net torque. I is 12.5. Alpha is negative 0.87. So result is going to be, as I remember, 12 negative 11. This is going to be the answer. 12.5. Result is negative 11. So negative 11 Newton meter is the net torque. Question number 39. A wooden bucket filled with water has a mass of 75 kilograms and attached to a rope that is wound around a cylinder with a radius of 0.075 meter. So this is the cylinder, and this cylinder has a radius of 0.075 meters, and a rope is wound around the cylinder, and finally from this rope a bucket is suspended. Mass of the bucket is given as 75 kilograms, and a crank with a turning radius of 0.25 meters is attached to the end of the cylinder. So we are going to attach a crank. So let me use another color for the crank. So this is the crank, and this radius of the crank is 0.25 meters, and we are going to apply a force, a minimum force directed perpendicular to the crank handle. Handle is in here, so we are going to apply a force, minimum force, the crank handle, to rise the bucket at constant speed. And what constant speed means, net torque acting on the cylinder must be equal to 0. So which means torque produced by the crank and torque produced by the bucket. So one of them is negative, the other one is positive, so they must be equal in magnitude, opposite in direction, so sum is going to be 0. So let's calculate the torque for each force because of the bucket and because of the force acting on the crank handle. First calculate the force produced by the bucket. Fg is equal to, we know, m times g. M is 75 kilogram, g is 9.81. So 75 times 9.81, if we use calculator, we will get this as 736 Newton. So 736 Newton produce a counterclockwise torque according to this drawing. So torque of a bucket is going to be positive as 736 times distance from force to the axis of rotation, which is the center of the cylinder, is the radius of the cylinder, which is 0.075. So let's find the torque times 0.075. Answer is 55.2. So torque produced by the bucket is positive 55.2 Newton meter. And this F minimum produces a torque, but this torque produced by this F is going to be negative. It's called a clockwise rotation. F minimum multiplied by distance from first axis of the rotation to the radius of the crank handle, 0.25. So because it's the constant speed, at constant speed, net torque must be equal to 0. Net torque must be equal to 0. And torque by the bucket plus torque by the force on the cylinder must be equal to 0. Torque by the bucket is 55.2. Torque produced by the force is negative F minimum times 0.25. Sum of them is 0. So when we take this to the left side, F minimum is times 0.25 is going to be 55.2. Divide both sides by 0.25 and 0.25. Result is going to be F minimum 55.2 divided by 0.25. Result is 221. So 221 Newton minimum force is required for rise the bucket at constant speed. This is also one of the chapter questions, first time asked in the chapter 2. Question number 40. A hollow sphere with a mass m and a radius of r. How long will it take the hollow sphere to from rest to roll 4 meters down an incline that makes an angle of 30 degrees with the horizontal? And this is also chapter question. The first time asked exactly the same. Even I remember the answer, and the answer is 1.265. This is the answer. It is a inclined plane. On an inclined plane, so you are rolling a hollow sphere from rest, which means initial angular speed is 0 or linear speed is 0. Both are 0 because it's at rest. And it rolls down 4 meters down an incline. 4 meters down an incline is the length of the incline, not the height. So this length is equal to 4 meters down an incline, and finally it reaches the ground. And this angle is 30 degrees given in the question. What is the time? How long will it take for hollow sphere from rest to roll down an incline that makes an angle of 30 degrees with the horizontal? So we need to know what is final translational speed at the bottom of the incline. And after that, I will use the kinematic equation for calculating delta t to cover this 4 meter distance. So I'm going to use the equation for calculating V final. V final is equal to root of this was the equation for an object rolling on an incline from rest to find the speed at the bottom. 2gh divided by c plus 1. C was the coefficient of moment inertia. It is the number. C is 2 over 3 for hollow sphere. And we need to know what h is. This height is needed to know because 4 meters is not that height. Height is going to be, hypotenuse is 4 meters multiplied by sine of 30. Sine 30. So it's going to be 2 meters. So we got the height. C, we are going to insert them all into the equation and we will find what is V final. 2 times 9.81 times h is 2 divided by c plus 1, which is 2 over 3 plus 1. Denominator, and I'm going to find what is V final. So just let's use the calculator. 2 times 9.81 times 2 divided by bracket 2 divided by 3 plus 1, close the bracket, is 23.5. After that, get the root. It is 4.85. So 4.85 meter per second is the speed of this hollow sphere at the bottom of the 4-meter long incline. Now I'm going to choose the kinematic equation for calculating the delta t, delta s or delta x distance covered by the sphere, or equal to 1 over 2 v initial plus v final multiplied by delta t. Delta is this 4 meter, 1 over 2. V initial is 0 because it's from rest. V final is 4.845. Delta t is the question. So when we continue with the mathematics, 4 times 2, 8. 8 divided by 4.85. Delta t is going to be 1.65 seconds. And question number 41 is again from one of the chapter question. A bat flies at a speed of 20 meters per second towards a fixed wall and sends an ultrasound of frequency 40,000 hertz. Calculate apparent frequency of the wave when it strikes the wall. Okay, the bat is flying. Let's say that this is the bat flying with a speed of source, because bat makes the sounds, it's a source, 20 meters per second towards a fixed wall. This is the wall, and because wall is fixed, wall is the observer in here, because we will calculate the apparent frequency of the wave when it strikes the wall. Yani observer is the wall which is fixed, that's why observer speed is 0. And source is the bat, it is the bat is the source, and source frequency or original frequencies 40,000 hertz. Calculate f prime on the wall. So equation for calculating f prime in for Doppler effect in sound. F is equal to f prime. So v plus minus v observer, v plus minus v source. This was the equation. But we know that observer is at rest, which is this wall. That's why this term is v is going to be 0. However, because it's an approach, in the approaching change, this is going to f prime, this is going to be f. Detected frequency is going to be always greater than the original frequency. That's why the denominator must be smaller than v. To make it smaller, the denominator must be negative. So then, if I want to calculate f prime, f is 40,000. V of the sound is given 340. The denominator must be 340 minus source, which is 20. In this case, f prime can be greater than f. So 40,000 times 340 divided by 340 minus 20, 320. Answer is going to be 42,500. So detected frequency by the wall is 42,500 hertz. So A is the correct answer. If the frequency of the third harmonic in a pipe closed at one end is F3, what is the frequency of the next harmonic? Pipe closed at one end, there are only odd harmonics, remember, F1, F3, F5. This is the next frequency after F3. We will calculate F5. And I know that F5 is 5 times F1. So first I have to calculate F1, after that I will calculate F5. So let's calculate first what is F1. This F3 is given. F3 is 3 times of F1. So then F1 must be F3 plus divided by 3. So F3 is 105.6 divided by 3. Let's calculate F1. 105 divided by 3, 105.6 divided by 3, it is 35.2. This is fundamental frequency. Then F5 is going to be 5 times fundamental frequency, which is 35.2. So multiplied by 5, answer is going to be 176 Hertz. So A is the correct answer. Question number 43 is the next one. Calculate, the solenoid has this number of turns per unit length of 4,000 turns per meter. Calculate the magnitude of the magnetic field in the middle of the solenoid when the current is 10 ampere. So we know solenoid magnetic field equation is mu I n over L. But in here, n over L is given. Number of turns per unit length, n over L is given. So I'm going to write this equation in this form. Mu I n over L. So then it will be much easier for calculating. Mu is given equation 4 pi times 10 to the power of -7. I is given as 10 ampere. N over L is given as 4,000. I'm going to write N over L directly, and after that calculate it. So let's use the equation. 4 times pi 3.14 times 10 to the power of -7 times 10 times 4,000. It's going to be 0.05 and 5 times 10 to the power of -2. 5 times 10 to the power of -2 Tesla is the answer. So this is C is the correct answer for this question. Let's continue with question number 44. A tuning fork produces a sound with a speed of 346 meters per second. So this is the V of the wave and the wavelength of 135 meters in air. So what would be the speed of the same sound in water? Because medium changes, speed of the wave will change. But frequency can never change for a wave while it's traveling from one medium to another. So we are going to use the equivalent of the frequency in here. So first let's calculate the frequency of this wave in air, and after that we will use the same frequency in water. So V is equal to lambda times F. So let's say V in air, lambda in air. So will give us, from this we will calculate the frequency of this wave, which never changes. F is going to be V in air divided by lambda in air. So V in air is 346. Lambda in air is 1.35. So frequency of the sound in air is going to be, or in frequency of this sound is going to be 346 divided by 1.35. Answer is 256 Hertz. And this sound travels to the water with the same frequency, which never changes. Then what is the speed of the same sound in water? Yani V in water is going to be lambda of this sound in water multiplied by frequency. Lambda is given in the water 5.853 multiplied by frequency of the sound 256. So result is going to be 5.853. So result is 1,500 meters per second is the correct answer. Question number 45. A coil with a 25 turns of wire is wrapped around the hollow tube. So this is N, and the hollow tube area of the tube is given, which is A. Each turn has the same area of the tube, so as the a uniform magnetic field is applied at right angle to the plane of the coil. So maximum magnetic flux is produced from this statement. We understand that if the field increases uniformly from 0, if the field increases uniformly from 0 to 0.55, which is delta B, is positive 0.55 Tesla, in 0.85 seconds, which is delta T. Find the magnitude of the induced EMF is the question. We are going to use the Faraday's law of electromagnetic induction, which is negative delta phi over delta T multiplied by number of turns. Because magnetic flux maximum in here, so I'm going to use the equation for magnetic flux A times P. But area is constant, B is changing. That's why I will rewrite this equation in this form. Area of the loops coils are the same, but magnetic field is changing. Delta phi is A times delta B divided by delta T multiplied by N will give us the answer. Area is 1.8, delta B is positive 0.55, N is 25, delta T is 0.85, so we will get the answer 1.8 times 0.55 times 25 divided by 0.85. Answer is negative 29. Negative 29 volt is the answer, so it is the correct answer. And question number 46. In the corresponding circuit as shown in the figure, calculate the phase difference angle between the total electric current and potential difference. So P's are given, so we are going to use the phase difference angle equation in terms of V, which is equal to tangent inverse V in series circuits, VL minus VC divided by VR is the equation. So tangent inverse VL is given as 10, VC is given as 4 divided by VR is 8. So tangent inverse, shift tangent, 10 minus 4 is 6 divided by 6 divided by 8, let's calculate this first. 6 divided by 8, answer is going to be 37, almost 37. 36.8, 37, 36.8, this is the answer. So question number 47, an AC circuit, AC source of effective value 50 volt is and frequency 1 megahertz is connected across a parallel combination of resistor 300 ohm, inductor of impedance XL 600, and a capacitor impedance is 200. Calculate impedance of the circuit. In parallel combination, impedance equation is 1 over Z is equal to root of 1 over R squared plus 1 over XL minus 1 over XC squared. So it was this equation. Now let's insert the numbers. 1 over 300 squared plus 1 over 600 minus 1 over 200 squared, and after that we will get square root. Let's start from the second term. 1 divided by 600 minus 1 divided by 200. It is 3.3 times 10 to the power of 3. Then we will square this. Square. Okay. Plus 1 divided by 300 squared, which is the first term. It is 2.22 times 10 to the power negative 5. After that, get the root of this answer. So we got 1 over z. 1 over z is equal to 4.71 times 10 to the power of negative 3. But we will calculate z. Z is going to be 1 over this number. We will flip left and right side. 1 over 1.71 times 10 to the power of negative 3. So 1 over answer is going to be 212. 212 ohm is the answer. Yani A is the correct answer. Question number 48. A light source of wavelength lambda illuminates a metal and then ejects photoelectrons with a maximum kinetic energy 1 electron volt. A second light source of wavelength lambda which ejects photoelectrons with a maximum kinetic energy of 4 electron volt. What is the work function? HFO is the question for this metal. So we know that as the wavelength decreases, energy of the photon increases. Yeah, and if this photon and that photon is compared, if you say this one has an energy of E, energy of the photon, the second one will have an energy twice, 2E. First photon, kinetic energy 1, and the second photon will have a kinetic energy, will produce a kinetic energy of electron, kinetic energy 2. 4 electron volts. So I'm going to use the Einstein's photoelectric equation, energy of the photon, which is E for photon is used for work function HFO plus kinetic energy of the photoelectron. I'm going to write this equation for both light. First light has energy E, and the work function of the metal, same metal, HFO, and kinetic energy of the first light is 1 electron volt. Photoelectrons gains a kinetic energy 1 electron volt from first light. Second light has an energy 2E, same metal, HFO, but this time kinetic energy of the photoelectrons are 4. So I'm going to calculate HFO, but I have to simplify E's. To simplify E's, I have to multiply the first equation by -2. If I do this, -2E is equal to -2 HFO, -2 for second equation 2E HFO plus 4. So when I add them side by side, so 0 is equal to -2 HFO minus HFO, negative HFO. So -4 plus 4 plus 2 electron volt. When we get this negative to the left side, so HFO is going to be 2 electron volts. So we got the work function of the metal. Question number 49. For which of the following objects during the rolling its translational kinetic energy equals to rotational kinetic energy? You know, total kinetic energy total is equal to translational kinetic energy, plus rotational kinetic energy for a rolling object. So these are equal. So I will say translational kinetic energy, if you say E, rotational kinetic energy is also E, and kinetic energy total is going to be twice of them. So for which shape was it? So maybe you remember we have an equation, a kinetic energy rotational divided by kinetic energy total will give us this the ratio of the moment inertia of the equation C divided by C plus 1. So we are going to check C. What is C for this shape? After that we will take it. Total kinetic energy, rotational kinetic energy E. Total kinetic energy 2E according to the above calculation, which is equal to C divided by C plus 1. So this will simplify. So then we will get 1 over 2 is equal to C divided by C plus 1. So we can get C from here. So you can go by mathematics quickly, or you can go by cross product. C plus 1 is equal to 2C. And after that you will get C to the left side, C is going to 1. So the shape whose C is 1 is from solid cylinder. No, cylinder is 1 over 2, not 1. Solid sphere, no, it is solid sphere is 2 over 5. Hollow sphere, 2 over 3. Tin hoop, ring, yes. This is the correct answer in here, D. And last question. A straight wire is put along x-axis. Find the direction of the magnetic field at point M along positive y-axis when the direct current to positive z-axis passes through the wire. So let's draw the XYZ coordinate system. This is positive x-axis, positive y-axis. This is positive z-axis. Question tells that Electric current is positive x-axis, positive z-axis. So we will put a wire. This is the wire. And electric current in the wire is positive z-axis. And we will look for the magnetic field along positive y-axis right here at this point M. Page now, because electric current is positive z, hold your pen perpendicular to your page and grasp it. Your thumb must show positive z getting out of the page. But keep your fingertips curled because we are looking for the magnetic field around our straight Y. We should curl our four fingers. Curl your forefinger until your fingertips comes to M, which is on the positive Y. When you do like this, your fingertips at the location of M, you will see that your fingertips point in negative z direction, negative x direction. So at this position, magnetic field is going to be in negative x direction. So this is the answer for this question.